Okay, so let's just continue operation transformation. Let's assume that two users input at the same time, at the same index. We know how to handle that. And insert the same character. What will our algorithm give? Did our algorithm, if they inserted the same position, different characters, what did the algorithm do? Compare the ID and order them in terms of ID. So did we do any special check for the same character? No. So we're going to get 2 question marks. Okay, is that what we want? Maybe not. Sorry, possibly.
What if there's supposed to be 2 question marks? What if we're typing the word move and I hit an O at the same time you hit an O? We still want there to be 2 O's.
So when I ask this question, what's the right answer? What's the correctness criteria? I mean, what do we, when we said no and you said yes, you're both saying that's the user's intention. This is not the user's intention, or that's the correct result. This is not the correct result. But we're just composing a sequence. We don't know what correct sequence is. Okay? So I've told you that there's a lot of work that's been done in this area, and they've gone back and forth between what kind of architecture will be used, what algorithms will be used, and they have gone back and forth about what the result should be. That I claim I do user intention better than others. Okay. So, what is the minimum requirement? The minimum requirement is that they both see the same thing. But then you can always see the same thing by clearing the buffer. So we said, well, work preserving. Let no insert be lost. Okay, at least when you're thinking of inserts. They're both work preserving. Well, maybe one insert got lost if I remove the question mark. Okay. So the title of this slide deck is Merge Policies. Whenever you use the word policy, you're indicating there's more than one answer. And the question is, how do we support multiple answers? Okay, that's now the issue I'm discussing. Okay. So this is work preserving. Everybody sees the same thing, but maybe it does not meet user intention. And that's an artifact of our algorithm here. So again, just to say this in text, that when everybody stops interacting, at some point finite time later, okay, they should all see the same thing. And the way to achieve that is to meet TP1 and TP2 if you're going to do, and TP2, yeah, both you have to meet. And that's the minimum requirement that can be met by clearing the buffer. And anything else is the whole thing. And it becomes tricky. And people have tried to give proofs of correctness without having a good idea of what intention means. Okay? So how to describe what intention is? And even if we cannot describe what intention is, at least given an algorithm, we should be able to say, this is what it does. Okay? And so there's more than one reasonable merge acceptable, and we can always have an application-specific merger. Okay, you can say I'm going to have this merger for this kind of user, and this kind of merger for this kind of user, this kind of document, and then we have the problem that we haven't quite described what the algorithm does. We just have to say, look at the code. Okay, so so when you write application-specific code, you can do it 2 ways. You can first say, my implementation does this. Your implementation does this, okay? And there is no way to share code among the implementations, the whole thing. Or you can say, my merge procedure, okay? We use the same filter, we use the same processor, we use the same OT manager, but here's the merge procedure, the transformation function. okay, if you will. That is different. So that you're going to fine-grained differences, okay, which is good, because when you go from one set of policies to another set of policies, you want as much of code to be shared as possible. Okay. So this is the state of the art today. If you ask most people, it's been a while since I gave a lecture, I guess. Okay. This is the state of the art where people say, oh, we've got merge procedures. Our merge algorithms are modularized so that the user just writes a merge procedure and they get what they want. Okay. But we want something even better. We want a declarative mechanism. Okay. Declarative means that you can, what does declarative mean to you if I just use the word? And what is it the opposite of? So when you write a program, you do some declarations, right? And you write some code. Okay? And it used to be that if you were programming in assembly language, you'd have fewer declarations and more code. If you're programming in a high-level language, you have more declarations and less code. Because a record type is just implemented through a declaration. You just say, I want a record or I want an object. You don't have to go and implement the object using assembly code. Okay? So it's nice to make more and more things declarative because you just specify what you want rather than how. And is there any language that you may know about, have you used, that is all declarative? There's no procedural at all? Anybody done a programming languages course? So there's functional programming, there's procedural, there's non-functional programming, there's object-oriented programming, there is logic programming. Okay, you just describe the rules, and the rules get solved. And then the problem is that, have you used Prolog? Anybody used Prolog? You used it?
Yeah.
So that's, do you like Prolog?
It takes some getting used to.
So you use the cut operator?
Yeah, it was a while ago. I took the concept class a couple years back.
Okay. It requires getting used to. Okay. And I'm sure C programmers will look at Java and say, it requires getting used to. What's all this inheritance and generics and exception handling, and so I guess, I'm still not used to it. So it takes, yeah. But the trouble with declarative is that the halting problem you run into. It's hard to prove that these things are right, and you need the cut operator, which is a way of saying you're cheating. That okay, I want the rules to be done this way, and I'm not going to leave the evaluation to the whole system completely. Anyway, I'm going there to just motivate a declarative mechanism here. Okay, then maybe you can do this task a little bit more declaratively than is being assumed by the state of the art. Okay, and so how can you come up with a declarative scheme? So what we're going to do is let's start bottom up. Okay, let's just start with sequences and just assume inserts only, like I did before. And we'll assume that insert the different positions are both accepted. Okay, let's just assume that. And the tricky part is tricky issue is when you inserted this at the same position. Right? So if you both users insert the same element at the same position, let's assume also that one is well, maybe we won't. We'll go and figure this out. Okay, and we'll try to solve both of these questions really, even though the slides are saying something else. That what happens when you insert the same position? Okay, this is what we're going to do right now. We'll expand this work gradually. Okay. So this is going to be our declarative mechanism. Okay. So this is actually the PhD student of my first student at UNC, okay, John Munson. And he came up with the idea of a merge matrix. Okay. The idea is that there are two users that we are merging at one time. Okay. We couldn't come up with an n-dimensional merge matrix. That was a little too hard to think about. Okay. So we said, okay, if any merging will happen two at a time. Okay. And I say we, this was mostly his work. Okay. Often with a PhD student, you have a lot of input, but in this case, there wasn't much. Okay. So let's assume that we've got our OT algorithm, okay, the client-server algorithm. And we've got a client operation at here, and we've got a server operation here. So, the lock compatibility matrix we saw earlier, okay, that was a declarative mechanism. You don't have to go and say, here's my locking scheme and here's my locking scheme. You just say, I'll just fill up the entries this way or that way, and I'll have somebody that interpret that that matrix, and we'll get this policy or that policy. Okay. If you guys have done security, there's a notion of an access matrix. Okay, where you just say this is the subject, the person who you're guarding the information from, the object, the information that you're guarding, and the cells are the rights. And you say when you set access lists, you're essentially setting the access matrix. Okay, so this was his idea was, why don't you come up with a merge matrix? Okay, where merge again has operations one user. In the case of concurrency control, you had operations one user wants to execute, and you had operations the other person had executed, or locks the person had got actually. Okay, and the operations got translated into locks. He said, just let's assume that these are the operations that the client has done, and this is what the server has done. Okay, and the server has done the operation before the client. And let's go and figure out how to merge them. Okay, so we've got the rows and the columns. Okay, and insert # means that they both. You will come here when they're both inserted the same position. Okay, we can try to be more general and combine this with the locking scheme we saw earlier. But let's just take that to be the case, that if both people inserted at position 2, then you'll come here. If both people inserted at position 3, you'll come here. So this is really a bound where it's a variable that's bound later. Okay. So in terms of Prolog, I don't know if you could remember this or not. It's a unified variable. Okay, it's a variable that takes the same value in multiple occurrences. Okay. So what are the choices here? Somehow the matrix is going to tell you what to do. I inserted a question mark, you inserted a question mark, both at position 5. What are some of our choices here? If you can enumerate the choices rather than write some code to do it, we're going towards a declarative mechanism. And we already enumerated, yeah.
So choices, we could print 2 question marks, we could print 1 question mark, we could print an exclamation point. We have options.
Okay, so exclamation mark point, you're getting me into trouble.
I didn't say that was a good option. I said it was an option.
Yeah, but we've got to look at good options. Well, the student who did this, John Munson, he had a very good GRE score. And he said, well, whoever had the better GRE score, we take his input. So he wanted to have his scheme allow that to happen. Okay, so I don't know if it's a good option or a bad option. So we could do many things, right? But except none, except one, which could be the server or the client, except both. Okay, so we're getting now to some choices that seem reasonable, given we already had some people imply that these are reasonable choices in some cases. So describes merge semantics of different insert operations at the same index. Not relevant when indices are different or insertions are the same. I'm saying insertions are the same because most people agree that if you insert the same thing, there's no point doing duplicate. Okay, but the merge matrix will allow that to happen. The question is, when do you actually consult it? Okay, and the way we looked at it was that you'll define your OT function or some other merge function as an interpreter of this merge matrix. Each application will first go and set some entries for the merge matrix, say this is what I expect to happen, and a user can then override that. So you can have user-specific policies or application-specific policies. Okay? Or some default values. Okay, and the goal should be that the defaults are so good that few applications override them. The application should be able to set values that few users override. Okay, that should be the goal. So what would you put as a default value here? This is judgment choice. As I can't prove one way or the other, but what's your instinct? Or systems that you've used, what would they do? Which systems have you used that support merging? Git. What will Git do if we both insert at the same position? Sorry? And it'll show you both. And then you have to fix it. Right? Dropbox. Have you guys done this? Sorry?
Dropbox creates a duplicate.
Creates a duplicate. Same thing. Okay. So now you're understanding in a much more abstract way some of these implementations, right? That they both do insert both. Okay. So cell choice. Perfect. And we can say that we'll just put one and both characters and let the user resolve it. Okay, and that's acceptable. Except earlier. Okay, so except the server. And the idea is that the client can see what the server did, okay, and correct it. Okay, the server, that means you can see what the earlier user. So we go in accept the choice of the earlier user. When we say accept server, we are saying accept the choice of the earlier user. The latest user will see pretty soon what happened, and they'll see that, oh, my change never got made. If they really want that change, they can fix it. Otherwise, we let the earlier go. Okay, that's one argument. Is there an argument for taking the later change?
The later change could have been done like in response to new information.
In response to new information, that's not here. The stock price might have changed. Okay, they may have the two users may have talked on the phone, and he said, okay, we agree that it should be high. Okay, and so we can do it client also. Okay, but the default, the safe policy is accept both, which is what you'll see in a lot of tools. So our cell choices are client, none, or both. Okay, and our default value will be accept both. Okay, I shuffled. Okay, so this can't happen. I inserted a position, you deleted the same position. That can't happen. If I've inserted, I've created a new position. Okay, so we'll assume this doesn't happen. Again, insert replace can't happen. Delete insert can't happen. Delete.
Like you can highlight a particular character and change it, right?
So highlight is a read operation, right? So highlight is not in my merge matrix. Okay. If I did, then that would be an interesting thing that I'm reading it. Remember, this merge just ignores, if you remember your transactions by now, whenever you do merging, you come up with a new transaction, and that's not equivalent of serializing the previous transactions. And you just forget about what's been read. Okay. So delete insert can't happen. Two guys delete the same element, except both. I mean, they both don't like it. Okay. Delete, replace. This is the most interesting one. What would you do? And what does Git do? Or what does Dropbox do?
Keep both.
Not keep both. There's only one to keep.
I mean,
Don't delete.
that only it.
Don't delete. Work preserving. When in doubt, keep the information. Right? There's a principle there. So you can basically have I mean, if you really are worried that people don't clear clear the information fast enough, then you would have a more aggressive policy saying, if anybody thinks it should be deleted, delete it. But what's the logic behind keeping the replacement and not deleting it? It's worth preserving. Is there some other high-level principle that you can think about?
Just the other user replace the things this user want to replace.
They want to delete.
Yeah, you want to.
So they didn't delete what the person, they didn't delete my information, they deleted the old information. And again, deletion people do to clear up things. And they cleared up something without knowing what it is. Okay? If you delete what I did, then that's not what they intended to do. Okay? So we'll just, when in doubt, keep the information. And delete means that I have no interest in this information. Replace means I have interest in the information, and this is the information. And if you knew what this was the information, you might not delete it either. Okay? That's sort of the logic. Okay? So okay, so before we do that, again, like I said, my slides are a little messed up. Tables, and we can assume that operations of different keys are non-conflicting. I put something, a value at a key. You put the value, some value at the same key. Which should we take? Based on what we said, just take the earlier one. Okay, so we let the server win. We both deleted. That's fine. Again, I put a value at a key. You deleted that key. What should be the result? By default,
Preserve the information.
preserve the information. Okay. So values, we'll just go and preserve the information, and delete means that one delete will be taken. I guess that's what this purpose no op means. No op means that one guy is deleted. So when this person goes to delete that key doesn't even exist. Just no op. Okay. here's the table situation that this person. Okay, record property. So that's, I'm going through these various objects to do what we try to do. What we wanted to do was build merging not for file systems or for a particular file. So what happens today is that you say, oh, Dropbox merges directory structures. Git merges a file. Okay. There are other schemes from people from Xerox have done something, a system called Bayou. They merge relational database systems. Okay. And there were all these these communities, and they didn't talk to each other. They published in different places. And we said, look, we're coming from a programming language point of view. We're going to merge objects. Okay. Now, we can't merge arbitrary objects. For the same reasons, we can't automatically merge arbitrary objects when we automatically replicate objects, as you saw earlier. So we're going to assume some patterns in the objects, and we're going to say the objects are really different implementations of three basic types and their compositions: tables, records, and sequences. Okay, every bean you implement is an implementation of a record, really, where a property is a field and a value. Sequence, you can have various kinds of sequences. We can have insertable sequences, non-insertable, just histories, as we've seen. And then we have various kinds of tables. We can have, okay, different implementation of table. So if we can take these three structures and their compositions, we cover a large space of data structures. And if we can cover these data structures and their merge policies, then we've gone from a procedural mechanism to a declarative mechanism. Okay? So you're seeing some information repeated here. Yeah, record is like the replace operation. That's because we're going to just different types, but using the same principles. Okay? So record is, we've got properties, and we come to this merge matrix when both of us have tried to set the same field or property. Okay, and we've already seen what that really means in the in terms of a sequence or a table. And what value? We'll take the server, we'll take the earlier value. This is the principle we've used so far. And here the idea is that you got a ticket price here, and I say 24, you say 24.1, and 24.1 came earlier, so we take that value. Okay, same principle, but a different data type. Atomic objects, what if it's just a string? You can't decompose thing into anything more. It's just an object. Okay? And again, the same principle, whoever changed the value first, we can do. Okay, so we were trying to cover the whole set of types that you can imagine in Java, including the atomic types. But
you list, like, it doesn't seem like in the past two data structures or objects you talked about that both was really an option. Like, you got both listed in the little table, like, but like in those, like, I'm thinking like, oh, why don't you do both? But you can't really do both with those object types, so we kind of eliminate that as a choice.
We eliminate that as a choice.
Okay. I just wanted to
Yeah, you're right. There's a set of choices. That's a good point. Okay, and both is not a choice when you can put only one value. When you have a sequence, you can insert both elements in there. When you have a table, what you could do is what Dropbox does is it creates a new key essentially with a new value. So if you both replace the thing at a particular key, you go and create a new key prime, which will say conflicted copy of this object. We'll give it a different name, and you choose between those two things. So that's an interesting semantics to have, that you just insert something which this merge matrix doesn't cover actually. Okay. So we could imagine adding a new property if that set of properties was dynamic and calling it property prime. That's a good point. So basic structure of this was that you've got a new type. And I just described these three types, but if you define a new type like stack, which we can't cover through our basic types, then for that type, you'll have to define a new merge matrix. And the merge matrix will be operation 1, operation n, and that's the structure. And you fill in these values, and we can build an infrastructure that, given a merge matrix, will interpret it. Whether the merge matrix type is predefined or user-defined is another issue. Okay? Okay, this is sort of the most interesting example case here. So we have this situation. I've got my name, somebody's name, and affiliation. And two users are messing around with the affiliation. Okay, one person says, oh, UNC. You know, of course, we guys in Chapel Hill are pretty snobbish, right? If we just say UNC, it means UNC Chapel Hill, right? Why should we bother writing Chapel Hill? Okay, if it's University of Wisconsin, which is where I went to, you don't go and say Madison. It's not Milwaukee, we know that. So, so this person is saying, let's be proper, and they probably mean CH. This person says, no, it's probably Charlotte. Okay? So we might end up with this. Okay? And what if I want it to be either UNCCH or UNCCC and not both? I don't want intermixing. One option is that I just say, okay, UNC. You know, both people changed it, forget it. Okay? But I really want, so what if I really want it to be UNCCH? Okay, and I don't want intermingling of these characters. Okay? How would I describe that? I'm talking about sequence of characters now. I want to take this sequence of characters from this user. As long as we're dealing with individual characters, I could say, okay, take server, take client. Okay? But how do I say all the characters from client? Or all the characters from server? Whoever comes first. I mean, you know, we can say first or last. Or we can say, you know, we can have a little table saying if it's UNC, then, you know, you can do something specific also, application specific, but let's just do something application independent.
You can do what Git does.
What does Git do?
Git keeps a history of changes.
Gets, okay, so we're assuming a history of changes is kept here.
Okay.
The question is, which history of changes do I take? I'm committing at each character. Think of it that way. When we're doing real-time editing, okay, I'm inserting this, you're inserting that. And, oh, sorry, let's assume, okay, we can even assume this happens, merge happens afterwards, okay? This person went along this path, this person went along this path, and now, indeed, we have a history and we want to merge. How can my merge matrix or some other abstraction describe what I want?
So if one user keeps doing the same action, then you consider that as some sort of pump.
So if one user keeps doing inserts again and again,
Yeah.
we somehow collect them together.
Then you do not perform one action, but you consider the sequence as a whole action.
A whole action. So that's the idea. Somehow we want to consider this to be part of one big action. And you're saying do some data mining and figured out that these were done by this user and they could be replaced by a bigger operation. And this was done by this user, right? But look at the way I structured this. What is the data structure being edited here, by the way? It's a table, right? Or it could be just, since I have only Joe here, it could be just a record with one field, which is, we can consider to be a sequence, another field, which we can consider to be a sequence also. When they went and added a dash and a C and H, they did what? They inserted an element into the sequence, right? Can you also model the operation as something different? They replaced this particular item. So you can deal with this change. This is a structured object. I hinted to you that the merge matrix works for compositions of types. Okay? And you can say I can either work at this level, at the high level, or at a lower level. And I'm going to express that through a merge matrix. Okay? That when you go and use the merge matrix, you can either be using the merge matrix in which there are two components here, or you can recurse down to a merge matrix for a particular component. That's the key. Okay, so let's go and see that in slow motion. So Joe and UNC are sequences in a record with name and affiliation properties. Okay, so think of there being a record or a bean with two properties with two sequences. That's what's really going on. Okay, and can we extend model to add the option of accepting all of the server or client changes to affiliation? Okay, that's the example. We want to go to an abstraction. So you need to capture multiple levels of change, which is what I just said. Okay. And this is the hierarchical document. There's a record, sequence. Sequence has got Joe and UNC. And what you can model this is as set affiliation. Set affiliation can be modeled as an operation that is decomposed into insert something at 4, insert something at 5, insert something at 6. Okay, so together these operations are a set affiliation. You know, that's what they did. You did set based on these 3 operations. And this person also did set affiliation by doing these inserts. And we can either be looking at the set affiliation operations, or we can be looking at these inserts, depending on what level in the hierarchy we are. Okay? And if we are at this particular point, we now add an option which says recurse. That please go down to the next level and interpret operations at that level now to do your merge. Okay, so you say merge at that level. And now you are going, so this is what you do. You add the merge property, and what you're doing is looking at, okay, I look at the set, I'm going to look at now these changes. I'm not going to look at the set change. I'm going to look at I4 and I4, and now we're going to get things intermixed. Okay, we are keeping both characters because we don't want to choose one or the other. So I'm having my cake and eating it too by allowing you to set the policy. Okay, that you can either say merge down to that level or not. Okay, and by the way, the same idea that we've got here can be used in diffing also. Okay, so there's some folks at CMU who use some of our work to do a diffing algorithm that can be doing diffing at either the high level, saying this paragraph got replaced by this paragraph, or going down to the lower level and telling the user this sentence in this paragraph got replaced with this sentence in this paragraph. And the scenario they gave for this was the lawyer example, that the lawyer probably wants to know that every little character that got changed, and they want the highlighting at that point. But otherwise, if you're working at a macro level, you just want to know that this procedure got changed. And you would imagine that this would be good, right? Have any of you used the diffing algorithm or merge algorithm in Word?
Not use it. If you see some patches, you can see some changes in some single line.
Yeah. They're beautiful. Okay, I mean, I just love in fact, one of the reasons I moved to Word was that and I looked for it and they had it. They had merging and diffing of PowerPoint also, but they took it out, I think. And they have a policy if nobody uses it, they just take it out at some point. But the trouble is often people don't use it because they don't know about it. So Word will do an excellent job of doing diffing between documents, but it won't do this multi-level diffing, which would be good. Okay? And it'll do a very good job of merging documents also. Okay? And in interactive UI, where you can select merge this versus that. You know. So merge matrix versus merge procedure. So something like this is a merge procedure. You can write different merge procedures, or you can come up with a merge matrix. Okay. And declarative is high level, allows easy customization, but it's less expressive. Okay. And you can make it expressive by making some of these entries themselves be merge procedures. That's what John Dye did. Okay, so he had a whole elaborate system where he had the merge matrix. He had default merge procedures, and those default merge procedures took default values. Okay, and you could and then you could replace. You could define your own types with those merge procedures, or you could define new types with new merge procedures. So it was one of these. Okay. And what it did was, the way we sort of justified what we did was, we couldn't prove the correctness of these policies, but we said, look, with this particular table, all the merge policies known at that time, we could cover. Okay? And there were a lot of merging that going on, even before Dropbox and Git. And this merge idea has been around for a long time. Okay? And had a mechanism to extend the matrix. Okay? Okay.